Hi, I'm John Merritt, Director of Applications Engineering at Ideal Power. Today, Mike Barron, Senior Firmware Engineer, and myself will be demonstrating the advanced microgrid features of our 30 kilowatt Stabiliti multiport power converter. All of our demos were recorded in Ideal's Research and Development Lab located in Austin, Texas. The 30C3 converter has a 3-wire, 3-phase, 480 volt AC power port and 2 DC power ports, enabling high-efficiency solar and storage microgrids in one compact enclosure, which weighs about 140 pounds. Multiple 30C3s may be paralleled to support larger microgrid applications. Our demo setup utilizes 4 30C3s in 120 kVA nameplate configuration. This first demo is what we call a synchronous start. We're going to bring all 4 converters online simultaneously to support a very large load. In fact, the load we'll be supporting is essentially 105% of their nameplate rating. We have 120 kilowatts of real power and 16 kVAR of reactive power. The system nameplate is 120 kVA, so you can see we're at the upper limits of the 4 units' ability to support this load. To put this in perspective, this building, when we're not doing this testing, consumes about 80 kilowatts on average in a summer day in Texas. So we're making more power than our office consumes. So we'll start off all 4 in the load, and the reason, again, we have to start all 4 is a single converter can't do this work. What's important here is we bring all 4 online simultaneously. Mike will demonstrate that, and then he'll also demonstrate a graceful synchronous shutdown. In this case, we bring the converters offline. And the goal here is to demonstrate the high quality and high fidelity of all the AC waveforms as we make these transitions. Lastly, Mike's going to do something that initially scared me. He's going to cycle this very rapidly. He's going to turn on and off the microgrid several times over a 5 to 10 second period. And so Mike, take it away.
All right. So on the LabVIEW monitor over here, you'll see each screen light up as I bring the converter online. I'm going to bring them online in a standby mode first. Once I have all 4 of them online, we'll do the synchronous start. So we have all 4 of them online. There's no activity yet because they're all in a standby state. I'm going to flip the switch here for our synchronous start. We've now formed the microgrid. And what I'll do now is I'll zoom in to show you the details of the startup. What you can see on the scope here, obviously we formed the microgrid, and it took right at about 8 AC cycles to start that up. Notice that it's a nice steady ramp, both in voltage and current. I have the voltage marked in red, and the current is in blue. Right now this is a very resistive load, so it is in unity power factor. Now what we're going to do is turn the microgrid off. This will be a synchronous stop. And let me zoom in on that as well, and we'll look at what the shutdown looks like. As you can see here, it's a very clean shutdown. There's no particular abnormalities in either the voltage or the current. And over here on the plots, you can see that all of the units have shut down, and when they were up, it was even distribution between all 4 units. We'll look very closely at load sharing as we do some of the load step changes in a moment.
Now what's important here is balance between these units. Each is operating right at its absolute limit. We need to ensure that every converter covers its quarter share of that total building load. And what we have displayed here are DC voltage on the bottom side and DC current, AC power, both real, reactive, and apparent. And so just a quick look, we're right at the maximum nameplate of 30 kilowatts. Each waveform is essentially identical, both when the microgrid started, the first time that Mike did the start, as well as the synchronous stop. So that shows you that these converters will respond as an aggregate group acting as one.
I'll start that up again, and you can see the load sharing. Up here, you'll notice the real power is evenly distributed as well as the reactive power. And then last but not least, as John mentioned, we can also start and stop this quite rapidly. So as you can see on the scope up here, we're running right now. That's off. That would be on. We've reformed the microgrid. We can do it as fast as we need to. So off, on, off, on. And as John mentioned, that's not something you would do in a real world. That's the equivalent of your little brother coming into the bedroom and flipping the light switch on and off quickly.
Except this is a very big light switch, a very big light switch. Thanks for your time today. We really appreciate you dialing into this microgrid demo. Please contact us if you have any additional questions regarding our products or technology, and have a great day.